Hi folks, we're going to take a look at the trig test. This is kind of the second one, but anyway, it's going to count for a lot, so do your best. You hopefully know what to do. This is our reference angle x, and we want to find the measure of angle x. And so we need to identify our sides. This is the adjacent side. This, of course, is the opposite side. And this is the hypotenuse. Remember, the hypotenuse is always across from the right angle. We're looking at SO, CA, TOA, and we have adjacent and a hypotenuse, which means we're talking about this one. This is the acronym for cosine. So the cosine of angle x is equal to adjacent over hypotenuse, that's 10 over 22. Approximately 0.5, more or less, but we're going to get the decimal, and then we're going to look up the cosine that has that decimal. There's lots of ways of looking at that. You can look it up on the table, or you can use your calculator. Either way works. I've got my table here. I've got my calculator here. We're going to do it both ways. 10 divided by 22. Let's get our exact value. 10, or more or less, divided by 22 happens to be 0.45 repeating. So 0.454 or 5, either one. That's the approximate decimal that gives us, the cosine of that angle gives us about 0.455. So we're looking under cosine, and we're looking for 0.455. This isn't it. We're looking under cosine, and we're looking for 0.455. And I'm not seeing it. Let me try again. Here we go. 0.454. Wow, there it is. This is almost exactly 63 degrees. Now that's called taking the inverse cosine, and this is what it looks like when you do that trig function. You take the inverse cosine of the cosine of angle x, which looks up the angle that has that cosine. And we use our calculator. We hit second cosine, and it looks like inverse cosine of 0.454545 and so on. And we are going to get very, very close to 63 degrees. And we are moving on. All right, let's take a look at number 2. Number 2 says we have a right triangle. Our reference angle is 29 degrees. We want to identify our sides. This is the opposite. This is the adjacent. And so we are talking about TOA. Tangent is opposite over adjacent. So the tangent of 29 should be equal to A over 8. And we're going to look up the tangent of 29. Again, you can look it up on your table. You can look up 29 degrees and find tangent, which is 0.554, approximately. Or you can use your calculator. And that's equal to A over 8. And I'm going to solve this by multiplying by 8 on both sides. And this is going to be a little more than 4. Let's take a look. We've got 8. Let me see if I can put it so you can see it. Times the tangent of 29. Now this is going to be accurate all the way out to here. If I only want to estimate, I can use my approximation that I had there, which is 8 times 0.554. And I'm going to get the same answer, more or less, 4.43. And in general, you want to put units, if there are any. Doesn't look like it. 4.43 if I round it. Moving on. I don't want to spend too long on this because I know some of you get tired. All right, so we're looking at, this is my reference angle. You need to identify your sides. This is the opposite side because it's across from the angle. This is the hypotenuse because it's across from the right angle. We're looking at opposite and hypotenuse, which is sine. That's sine is opposite over hypotenuse. Sine of 51 degrees is equal to y over 12. And we can look up the sine of 51 degrees. And I'll show you where it is. It's right here, 0.777, lucky number. 0.777, approximately y over 12. And we're going to multiply by 12, and we're all done. And we've got 0.777 times 12. Looks like we're looking at about 9.32. You could have taken sine 51 times 12 and gotten a more accurate answer, but there it is. It doesn't look like it's in feet or anything. Remember, these questions are on your Canvas test, so they may ask for specific units. I didn't write them down on my notes here. Oh, look at this. See this semicircle here? Well, this is actually a quarter circle right here. Right there. That's part of a circle. And the thing about circles is that the radius is always the same. This distance right here is the same as this distance right here, which happens to be the same as this distance right there. That distance stays the same distance over from the center here, or from the origin. All right. We want to find AB. Now, hopefully you know that if you've got this point, 4, 3, you should know that this is a special right triangle. 3, 4, and this is called a Pythagorean triple because 3 squared plus 4 squared just happens to be 9 plus 16, and that's 25. And remember that a squared plus b squared is equal to c squared. So this third side is 5. Exactly. Not approximate or kind of. It's exactly 5. This is one you want to memorize. 3, 4, 5 is a Pythagorean triple. You could double it, you could triple it, you could multiply by any number, and it'll still be a right triangle. Anyway, we are interested, though, in the distance from A to B. So you need to think about it a little bit. We know that this distance is also 5. And we know that this distance is 3, and so is this one. That gives you the answer, which of course is 2 units. Okie dokie. Number 5. Oh, got a little palm tree. I think this is supposed to represent a guy wire helping to hold it up so it doesn't fall over in the wind. We have a reference angle of 32. And what side is this? Of course, this is the adjacent side. And this is the hypotenuse. And we're looking at cosine. So the cosine of 32 degrees is equal to 6 over x. Oh my goodness, I hate it when this happens. This gives students all kinds of problems. That x in the denominator, you can't solve for it directly. You're going to have to multiply by x on both sides. And we've done several of these examples. Some people are still having issues with it. I can look up the cosine of 32 and estimate it. And we'll look at the cosine of 32, which happens to be right there, 0.839. Yep. Is that 33? Nope, 32. There we go. 0.848. 0.848. And that multiplied by x will be approximately equal to 6. Now, all you have to do is divide by the decimal, 0.848. Hopefully I got it correctly. I think I read it correctly. 0.848 divided by 0.848. And we are going to get x, which is the length of the guy wire in feet. And we'll do that division. And I'll actually do it with the cosine of 32 as well. 0.848. And I'm getting 6.8 feet. 6.85. That seems reasonable, I suppose. Although it's not going to do much for a 30 or 40 foot palm tree. Anyway, let's take a look and make sure we take 6 divided by cosine 32. And I should get the same answer. What? Maybe I did read it wrong. Let me look up cosine of 32 again. Cosine of 32, 0.848. Wow. Interesting. Huh. Is it possible my mode's wrong? No? Try again. 6 divided by 0.848. Oh, there we go. No wonder. There we go. That's a good thing I checked it. What I had done is my division didn't hold in, and then I just put 0.848 behind it. Duh. 6 divided by cosine 32 is 7. 6 divided by 0.848 is 7. So it is approximately 7.1 feet. Jeez. Watch out. 7.1 feet for my guy wire. Sorry about that. All right, number 6, it looks like we have a slope leading down to water. This is called an angle of declination. That angle alpha right here, that's called an alpha. It's not a fish. This is my angle of declination down to the water. This, of course, is a right angle. And we're interested in, maybe we're looking for the angle of declination, given that we want to go this far out, and a ramp of this length. Maybe this is a boat ramp or something, and we need to know the angle so that we can see if it's safe or not or something. Anyway, this is going to be my reference angle. This is adjacent. This is hypotenuse. And of course, we're looking at cosine again. So the cosine of alpha is equal to 85 over 92. I'm going to make sure I can see correctly. If I look up here, I can actually see it better. All right, I want this as a decimal, and then I'm going to look up the angle that has a cosine of 85 over 92. So I'm going to take 85 divided by 92 and get a decimal. Looks like it's about 0.924. And I'm going to look up the angle that has this cosine. That is called taking a inverse cosine. And I'm looking for cosine of 0.924. 0.924 cosine. Geez, it's looking right in between these two right here. 0.927 and 0.921, right in the middle of 22.5. Alpha is approximately 22.5 degrees. Now, what I can do, of course, is take the inverse cosine, which is that trig function. Inverse cosine, and I can actually use the fraction, and then I'm very accurate. So I'm going to take my fraction and take the inverse cosine of 85 over 92. And there it is. You can see it on the calculator. And we should get 22.49, almost exactly 22.5, right in the middle. 22.5, and you do want to put units on it. If you don't put degrees, calculators, engineers, and so on assume that you're talking about radians. All right, I know we're going over time. I'm sorry, guys. I just want to make sure I get them all in there. All right, what do we got here? Looks like we have a reference angle of 25, and we want to find the perimeter. That means we want to find the distance around the entire triangle. Now, we could find x and then use Pythagorean theorem to find y, or we could find x using opposite and adjacent. That's going to be the tangent. And then we could find y using the adjacent and the hypotenuse, and that's going to be the cosine, and we could find those two that way. And then we could use the Pythagorean theorem to check our answer. So that's the way I'm going to do it. I am going to set it up. The tangent of 25 degrees is equal to x over 24. Pretty easy one to solve. I'm trying to keep it in this view here. And we're going to multiply by 24 to solve this. And we're done. X is approximately equal to 24 tan 25. And I got 11.2. So X is approximately 11.2, which seems reasonable. It's a little less than half. If this was 30 degrees, this would be about half, more or less. So there it is. Let's see, we've got these two, which is going to be the cosine. Let me zoom out just a little bit so you can see it a little better. And this time I'm going to use cosine because this is adjacent over hypotenuse. Oh, this time we've got a problem. This time the 24 is on top. This is the 25. And this time it's 24 over y, isn't it? I've got to multiply by the y on both sides and get rid of it. And then I'm going to divide by the cosine of 25. That's just a decimal on both sides. Sorry, I didn't color code it. And I get y is approximately 24 over cosine of 25. I'm going a little faster because some people are going to get antsy here. 24 divided by cosine of 25, and we're looking at 26.5. The nice thing is that, centimeters, not feet, darn. Okay. So this one is 26.5, which seems reasonable. These two sides look more or less equal. Of course, we know the hypotenuse has to be the longest. So 26.5 seems reasonable. 11.2 seems reasonable. And I'm going to use Pythagorean theorem to double check it. It should be very easy to do with the calculator because I can take my 11.2. Now remember, that's only an estimate, so it's going to be a little off. Plus, and I squared it, a squared plus b squared, 24 squared, and square it. Did I square it? Yep. Now that's going to give me about 701. Now I'm going to take 26.5 and I'm going to square that, 26.5 squared, and it should be equal. And realize it's going to be a little off because these are rounded. So looks perfect. Looks like we got it. We wanted to answer the question asked. We want to find the perimeter, so you're going to have to add up all the sides. That's going to be 50.5. That's going to be 61.7. I added in my head, but you can grab a calculator and hopefully you can see that's correct. And we're moving on. Let's see what we got here. Number 8. I want angle R. There's my reference angle. This is opposite. This is adjacent. And it looks like we're looking at tangent. The tangent of angle R. I guess I could call it, I'll just call it R. It's kind of weird, but there it is. Tan R is equal to 17 over 63. And we're just going to look up the decimal. Again, that's called taking an inverse tangent. So I am going to, I'll just take the 17 divided by 63. And I get about 0.270. 0.270. And I want to look up the angle that has that tangent. So I'm looking up tangent of 0.270, which is right about here. This is really, really, really close, which seems to indicate 15 degrees. So I'm going to say that R is approximately 15 degrees. Let's take a look at the calculator and use inverse tangent this time of 17 divided by 63. And there's my 17 divided by 63. And we should get about 15 degrees. We get about 15.1 if we want it to be a little more accurate. Degrees. There it is. All right. Almost done, guys. Almost done. Yay. All right. Got 23 degrees. This is our reference angle. We're looking at adjacent and hypotenuse. Should be good by now. Cosine of 23 is equal to adjacent over hypotenuse, 27.3. We're going to multiply by the 27.3 on both sides. And we're done. That's it. E is approximately 27.3 times cosine 23. And we're looking at about 25.1. Let's see if it seems reasonable. Yeah. You see, this is a fairly small angle, which makes these two fairly close to each other in size. And this one, of course, is smaller because the hypotenuse is always longer, yada, yada, yada. 25.1 meters in this case. Notice that I called it E instead of DF. You could call it DF, that's fine. This is the length of the line segment DF. If I want to talk about the line segment itself, I put the line segment over it. The reason I like to use the little e is because it's a little easier to explain as a variable. And notice that the little e, is across from angle E, and they are related to each other. Anyway, lots of stuff going on. Number 10, we've got an angle Y, that's a reference angle, and we're looking at, it's upside down. A lot of people are going to mess this up. Be careful, this is hypotenuse, this is adjacent, and we are talking about cosine. Cosine Y is equal to 18 over 20. Easy to make a mistake there. That is 9/10 or 0.9. In fact, it's exactly equal to 0.9. And we're going to look up the cosine. What angle has a cosine of 0.9? That's it. What angle has a cosine of 0.9? And there it is, almost exactly 26 degrees. Y is approximately 26 degrees. Again, this is an inverse cosine. Inverse cosine. The name of this is also an arc cosine. That's another name for it, arc cosine. They will sometimes write it that way, of 0.9. Same thing. Anyway, let's take a look. Inverse cosine of 0.9. We are looking at 25.8. In case they wanted to round it, if I wanted a little more accurate. That's the problem with tables, is that you can only get within 1 degree more or less. There you go. Approximately 25.8 degrees. Last one. Oh boy. Looks like we've got a reference angle of 40. We've got an opposite and a hypotenuse. Looks like a sine to me. Sine of 40 is equal to b over 17. Oh, easy one. Multiply by 17 on both sides. I guess I should have done it in red. Oh well. 17 sine 40. Sine of 40 is about 0.643. Approximately for my b. And of course I'm going to use my sine 40 in my calculator. Sine 40 gives me 10.93. Let's do 17 times 0.643. See if I looked it up right. I'm sure I did. Yeah, about 10.93. Okay, guys, sorry it took so long. I hope you got it and you got 100% on your test. And I will see you back again. Bye.